question I should have asked you guys, but didn't.
Why are we so excited about SUI?
Welcome to the Open Metaverse podcast. I'm your host, Mehdi, Senior Tokenomics Analyst at Animoca Brands. Today, we have special guests with us, and I'm honored to have them on show. We have co-founders of SUI. Guys, welcome to the show.
Thank you for having us.
Thank you very much.
I first want to touch on SUI's key innovation, and I want you to explain it to me like a 10-year-old DJ. So the first key innovation I want you guys to explain to me is object-centric data model that you guys have developed at SUI.
So let me take it from a very high level point of view first, right? If it's explained to 5-year-old. So everybody talk about blockchain's power as being tokenization of assets, right? So when you think about how tokens work today on all the other blockchains, like EVM chains in particular, right? Tokens sort of represent an ownership in an underlying asset that lives off-chain, right? And that means you can only tokenize asset that's basically finalized, that's already completed, that's not going to change, it's not going to incur, you're not attaching more information to it, which is a very, very big limitation. If you think about it, right? If you're thinking of signing a business contract, you have parties, counterparties, you have this process where you accumulate a lot of information along the way. And then at that point in time, it's finalized. So that's very, very different. That's very limiting, right? Even thinking about using this as a business contract for, as a something for kind of tokenizing a business contract. So we built SUI to really change that, right? So when you're thinking about an object-centric model, you can accumulate a lot more information. You keep a lot more information. The developer can define it onto the chain, right? What the asset look like, what actually fields and metadata actually, captures. And if you want to append more information to it later on, you can basically attach another objects to it, right? So think about something as trivial as an asset such as a baseball card. If I have two identical baseball cards, both pristine, you create them as, let's for the lack of a better term, NFTs. Later on, I meet that baseball player in real life. I should be able to pull out my phone, look at my NFT, that's your baseball card. Can you sign it for me? And that adds more information, adds more data to that object, to that asset. That makes 100 times more valuable. What's the equivalent of this in the blockchain world? So tokenization, the model that worked in the past with all these blockchain, in our opinion, just fundamentally is very flawed. So and that's very limited, and that's the primary reason why we haven't seen much innovation in terms of consumer-facing product as a result. Another thing that's very, very important to know, right? What comes along with an asset? Rules around the asset, right? What is the rules you have to satisfy before you create the asset? What are the rules before you can transfer the asset to another party? Just look at the issue with NFT markets, right? Right now, what we're seeing is the marketplace decided they're not going to pay royalties because it's fundamentally misaligned with their interest. They want to increase the volume of trading. They don't care about satisfying the demand of the creator of the asset, which is creator. Say, pay me royalties when they're secondary sale. Everybody in art knows that's where you make the money, is collecting royalty in secondary sale. But the marketplace decided, not going to do it. We're just going to do whatever we want. What is the whole point in this? To go back to centralization. So you have to enforce rules around this asset. And the only way to do it is embedding this restriction, these rules verification inside the smart contract that defines the behavior of these assets. Not rely on sort of essential social consensus among all the players, such as the marketplace, such as everyone else is involved in the transaction to be the good player, right? Again, so That might be a long answer. Hopefully it's not, it's clear to you. This is a very, very different way of thinking about the blockchain, because ultimately a blockchain is useful as a platform for disintermediation of assets. And in our opinion, all the blockchains have failed at that.
So a follow-up question by the way, it's a good explanation. So a follow-up question that naturally comes after this is, within circles, the most discussed thing about SUI is parallel execution, and the object-centric data model actually helps with that. So can you also explain to our audience what is parallel execution and how does the data model helps with that?
Yeah, sure. So I can go into more detail on that. So, right, if you look at what a blockchain is doing from a computational perspective, you have a transaction, it's creating assets, it's reading and writing existing assets, it's deleting them. That's sort of all it's doing. And so when you're talking about parallel execution, what you want to know is when are transactions touching distinct objects, and when they're touching distinct objects, that's when you can do parallel execution. If they're touching the same object, then, well, maybe you can, maybe you can't. It depends on the flavor of operation. But like the flavor of parallelism that's most useful is, hey, these are touching different things, so I know I can do them in parallel. And the way the object-centric data model helps us with this is that each transaction specifies the objects that it's going to touch. It says, hey, like I'm going to use this NFT that I own. I'm going to be touching this marketplace. I'm maybe going to be putting it in this multi-sig wallet. And this is transparent in the transaction format. You can see it without even running the transaction. So from the runtime perspective, we have a couple of different tricks that we play. So one trick, and this is probably the one you've heard about the most if you heard about SUI, is sometimes for certain types of computations, we don't need full consensus. If you have a transaction that's only touching single owner objects, maybe it's an NFT transfer, maybe it's combining two coins, maybe it's doing a payment, things like that, then we actually don't need to go through full consensus at all. We can use something called Byzantine consistent broadcast that's a lot lower latency and that's trivially parallelizable. You just say, okay, every transaction that falls into this bucket is parallelizable by construction. And we see in practice that many, many transactions fall into this bucket. And then for many other cases, we have something that's not inherently parallelizable because it has what we call a shared object. Maybe you have a DEX and there's two different users that are making a trade on it. Well, we have to sequence those trades to see who gets which price. Or maybe two folks are trying to buy an NFT on a marketplace and we have to know who bought it and who misses buying it. And so what we do there is, in other blockchains, these transactions would all be sequenced with respect to each other and would either be executed sequentially or we'd sort of try to discover the parallelism on the fly. Whereas for us, we can see, okay, we just generalize the logic that we're using for single owner objects a bit. We say, okay, if you're touching distinct shared objects, I can run those transactions in parallel, no problem. And if I'm touching the same shared object, then we have all sorts of execution strategies that we use. We sort of have worker threads. We throw transactions that are touching the same object on the same worker thread, and other ones get run on different threads. And so we maximize the parallelism as much as possible. And then the other thing that this lets us do, which is quite interesting, is, okay, like if someone gives you a workload with a lot of parallelism, great, you can execute it in parallel. But the thing in blockchain, a lot of the workloads that are touching shared objects are creating a lot of contention. So you want to have your economic model also hooked into this and make sure that you're incentivizing users to give you workloads that don't create a lot of contention. And so what we're doing that is something that we call object-centric fee markets, where we sort of track the hotness of a shared object, like how many transactions have touched this in the last couple of checkpoints. And then you have to pay a higher gas price to have the transactions touching that hot object be executed in a fashion with a better quality of service. And so what this does is, if there's some hotness that's going on in some area of the chain, the gas prices will go up there, but the gas prices that are touching other shared objects that are under normal operation that aren't hot won't go down. And there's a huge problem in basically every other blockchain where it's like, oh, you have something really hot that's going on, and the chain, even if you have parallel execution, the chain slows to whatever its sequential throughput is. And we have this economic feedback mechanism that will prevent that from happening, because the prices will basically go up in one spot, but then the other lanes will just keep running along at full speed.
So if my understanding is correct, does that lead to a local and a global fee market?
Yeah, that's right. So it leads to, I guess, these hyper-local fee markets, where the fee markets can be per object or per collection of objects, that there's a lot of shared objects that tend to be used together, instead of having something global where, the analogy we like to use is if there's Uber surge pricing in San Francisco, that shouldn't make that shouldn't cause there to be Uber surge pricing in New York. But that's but other blockchains do work that way because there's a global fee mechanism. And so we're doing something a lot more fine-grained.
Yeah, so just to understand this better, how is the parallel execution of SUI different from some of the other competitors? Like Near is using sharding, Aptos and Solana also using some different approaches. So can you just highlight to our audience what are some of the similarities or differences in terms of the approach SUI is taking?
Yeah, so I think each of these is doing something quite different, and so I could talk through each of those, but I think it's easier to paint with a broad brush on their general themes. So I think the general themes are the biggest general theme is I think this thing of can you hook in? Does your economic model prevent hotspots? That's something that we're doing. That's something that Solana is also doing. They have these local fee markets that have been rolled out recently. I think that's extremely important because otherwise you're relying on your users to give you a workload with a lot of parallelism, and we've seen from the way folks use blockchains that just won't happen. So I think check mark for say Solana and for SUI on that point, and not for others. And then this is related to this concept of optimistic versus pessimistic parallel execution. If you know upfront what a transaction is going to do, then you have perfect visibility into this is touching something hot, I should charge more for it. Whereas if you have something that's doing optimistic execution, you're going to discover that you're creating contention at runtime when it's already too late to punish the user by charging them higher fees. So I think that's another important axis to consider here, and something that we're doing with SUI. And then in terms of sharding, this is not the same thing as parallel execution, but closely related. Like an important problem is, if your strategy for parallel execution is I have everything in memory and trying to do something optimistic by sort of detecting conflicts in memory on the same machine, that's hard to scale up because you have to keep getting a bigger and bigger machine and more cores. Whereas if you have something where the data model lets you do cross-machine sharding, and this is the direction we're going eventually, I have 20 machines, and then these machines are responsible for these shared objects, and this machine is responsible for these ones, and each of these is independent workers, and I know where to throw things so I can schedule them in parallel. Then that's a very different approach than something that's detecting conflicts in memory.
I'll say something more, just kind of summarize it. Execution usually is only a small part of the entire transaction pipeline. It's often not even the bottleneck, at least based on our data. Execution is only a small part. We can potentially paralyze the entire pipeline of transaction processing, not just execution. Because we have dependency information, we can aggregate transactions processing based on actually dependency, not having to do a total ordering of unrelated transactions.
For us, a net benefit here is ultimately SUI gets to behave kind of like you expect a really large distributed database that large companies already run. So with Google or Facebook, as you have more load, you throw in more resources and you could take on the load. At Christmas, if everyone's posting pictures, you need more machines to manage their increased load. And when Christmas is over, you could turn those machines off. That's kind of like how people should start thinking from a SUI perspective, because we enable validators to essentially scale up their resources to accommodate for the increased demand. And similarly, the economic model has been designed in such a way to take advantage of that. Namely, the price that you pay for gas is pretty much flat over and over again, unlike traditional blockchains where things, the fee, depending on the price of the token, can really get away from consumers. Whereas in SUI, even as you see volatility in the price of the token, you shouldn't see great difference in price that you're paying for gas from a dollar perspective, which we think is a better form of UX as well across the board.
So you did highlight the economics of the gas fees. I would also love to learn more about the storage fund, which I think is pretty novel. So if you guys can highlight what's happening there in terms of tokenomics and economics behind that.
Okay, so let me back up and talk about the problem that the storage fund is trying to solve. So there's basically two different things that we care about, right? One is making sure that folks have an incentive to clean up the cruft that they leave on the blockchain. And then another problem is the sort of, I call it a time travel problem, where if I'm a validator today and someone allocates a bunch of storage, that you don't want it to be the case that validator gets paid by the gas fees of the current transaction, but then some different validator, 2 years in the future that's still storing the same thing has no economic benefit from that. That doesn't work. It doesn't help validators fund their operational costs or set up storage for the long term. So the way we solve both of these problems is with this storage fund mechanism. And so what happens is when you send a transaction and it creates some objects or otherwise allocates some storage, each object remembers, hey, I've paid this many SUI to allocate this object. And we basically have a price per byte. And then if you come back and later free that storage, then you get a refund, not quite 100%, but I think today it's 99% of the amount that you paid. So that way you're not just going to leave objects sitting around because you're literally leaving money on the table. Your incentive is to free these objects and reclaim the storage fee. And then the other thing, and so that solves the cleanup problem. And then the other problem of this, of having this transfer across time, when you pay this money, it doesn't go to the current validators. It goes into a big pool on chain, and that's what this storage fund thing is. And the current validators, they earn staking rewards from the funds that users have staked with them, but they also earn staking rewards on the money in the storage fund. And so what this does is it creates this perpetual revenue stream that's proportional to the size of the data the validators are storing. So they don't have this issue of, that I'm having to store terabytes and terabytes of data, but no one is paying me for that. Like, they'll get staking rewards that are proportional to the size of that storage fund. So our brilliant head economist Alonso came up with a scheme. I think it's quite clever, and we see it working out pretty well so far.
Yeah, interesting thing about that, if you think about NFTs, right? You have a bunch of these NFTs sitting around, some that have no value, some with value. And imagine 5 years' time, your NFT is no longer popular, no one's really trading it, or no one's as much interest in it. But the amount of storage that it consumes is significant enough where you just think, well, if I just burn this NFT, I will get the SUI token, at least 99.9% of the SUI back that was used to pay for storage, which is quite an interesting way to imagine what UX people could build there to give you an idea of here's this valueless NFT. Why don't you just destroy it and get some money back rather than keep it lying around? Also, it gets people thinking separately about what storage really means. If you're paying for storage, you can almost argue storage is relatively free. You're holding some capital on a table to store an asset. And once you clear that asset up, you can get some of that storage back. So we built SUI to enable people to store the JPEGs on chain. You can actually store more complex data structures on SUI than you can on other blockchains. And that allows you to create more innovative ways of engaging with consumers. So we're very excited about that.
So a follow-up is that in terms of a TAM, or in terms of the opportunity, many L1s do not have on-chain storage, and some of the competitors out there, let's say Arweave and Filecoin, has on-chain storage. So in terms of the TAM available, is there a correct mental model to kind of think of SUI as a hybrid of L1 as well as a on-chain storage? Is that the right way to think about this?
I'll probably say no, in the sense that, if imagine what you do in Ethereum today, you store a record of ownership and then you store a link to some JPEG on IPFS. IPFS is great for that, but really that asset is really static. I think the value that SUI brings is you have assets on chain that are no longer static, that can actually be dynamically changed with respect to how you engage with them, which is way more valuable than just dumb storage. So we like to think SUI is a better model in the sense that, you have really dumb block storage that is always going to be there if you just want to have static assets that never change. But if you want assets that have behavior mechanisms where you can dynamically change them based on how the NFT performs, or there's a game that wants to change the look and feel of a character over time, that's more valuable in terms of storage. And I don't think we're arguing that SUI will be cheaper than Arweave. It certainly will be a lot cheaper than storing on ETH or Solana or any of the other blockchains to a large extent, right? So, and then you add on the fact that you can get money back if you destroy assets. It's an entirely different game. Evan, sorry, I didn't cut you off.
Yeah. Let me add on to it, right? It's coming back to our first conversation when we talk about tokenization. On token is very static, it's very one-dimensional. So think about it, right? When you think things that's object, right, and the objects are vergent, right? So when blockchains are basically a ledger that tracks the history of transfers of these static asset, you add a dimension beyond that. You're also tracking essentially the state changes of these assets on chain as well. So that's the better way to think about it. We're not trying to build another blockchain that basically do very, very basic stuff, right? We're tracking the record of how these static assets are changing hands, right? We're also tracking, basically sort of almost like having another ledger for each of the assets, track the history of how these assets changes over time. So that's the way to think about it.
Excellent. So I want to go back to horizontal scaling. So hypothetically, imagine we are in 2025. So what will be the North Star in terms of TPS that SUI will be targeting? And when I say TPS, I mean average of, let's say, simple transaction as well as complex transaction combined together. What will be the North Star for you guys?
In 2021, there's roughly 5 million activities that happen per second in the internet, right? So the activity can be a Google search, can be liking Instagram photo, can be watching a TikTok video. These days can be probably increasing. So on one hand, that's no North Star. On the other hand, that's completely wrong way thinking about doing things, right? Because TPS is not going to be this sort of thing you look at when this space matures. When you're thinking about using infrastructure, you don't ever think about capacity being a limiting factor. You want to think about what they can do for you, and you want to, depending on them as your business grows, right? They're just never going to run out. So this is why horizontal scaling is very important. It's not just horizontal, it's horizontal and done on demand. When you need to increase capacity to meet demand, you can increase on the spot. That is the important feature you're looking for. Now, next month or next few weeks down the road, I can increase my capacity to meet the demand that's coming today. That's completely pointless, right? Because when you have infrastructure that doesn't meet demand, you have failed completely. What we're seeing today on Ethereum is a complete failure, right? People talk about it in a way that's almost like a good thing. It's not. It's terrible, right? This prevent real product builder that want to build a business from using your infrastructure, because you cannot allow the underlying infrastructure limitation in capacity to stop you from making business, right? Stop you from serving your customer. So I hope in a few years' time, people don't talk about TPS. People just talk about, is this infrastructure, blockchain infrastructure has uptime, has a guarantee to service my product, right? And that's the only important thing that we should care about.
So to follow up on that, since we are in Web3 business, let's say we have that infrastructure which is scalable enough to support many businesses. Is there any Nakamoto coefficient, which is sufficient enough that allows that security, that trust guarantees whilst having that scale? Do you guys have any North Star for that?
So here's another thing we think somewhat differently from everyone else, right? You can have several thousand validators and all that, but we all know, because we're in the Byzantine, kind of model, only the 2/3 majority we have the most, kind of voting power can make the decision. So what we do is we want to encourage open market, dynamics for everyone that runs a node, run a validator, to want to be in the top 2/3, so they can actually actively get involved in the transaction processing, right? Because they can get the booster reward, which then pass on the booster reward to their customer that stake with them, right? So that's very important. This is why this model where you perpetually sort of incentivize validators to be running a node is a bad one, because once you fall out that top 1/3%, you don't actually have the incentive to improve upon your service, right? We're seeing this a lot, right? You can have many thousand validators. The one that have 0.01% just collecting money for nothing, for doing no work, right? You're kind of in the validator set, but you're doing absolutely nothing. You're never called upon to vote. You never call upon to do anything, and you don't have the incentive to improve upon your service because I'm getting money for free, right? So we think this is a wrong model. We want sufficient, degree of decentralization. Nakamoto, kind of numbers are important. This will increase over time. But the most important thing, what we want to see is an open market dynamic where the validators are working hard to improve on their service, to offer their customer better returns, so more people stake with them, so they can squeeze into that top, 2/3 or whatever the number, so they actively participate in the consensus, in the voting, in everything. So then they get more business, right? So that dynamic between the validators is very important. So that is the model we're kind of utilizing.
Running a validator in SUI over time is actually going to be very competitive, because there are a few things you've got to keep aware of as a validator. One, you're going to be actively called to vote on what the gas fee should be for transaction. that's something where it's going to be dynamic. You're going to be pricing gas fees relative to your infrastructure costs. So you're incentivizing people to run efficient infrastructure that scales, but also is something they can make money on. And if you're running very expensive hardware and you can't compete, you'll be kicked out of and run out of business very quickly. So there's basically a market to compete as a validator from that perspective. Also, if you don't scale your hardware fast enough and everyone else is processing more transactions than you, then what happens is you essentially get slashed as a validator and you start to lose rewards. And hence you would have a sufficient amount of stake leaving your validator and going to others who are scaling the infrastructure. So one, where the tokenomics is set up in a way to encourage validators to run efficient hardware and be profitable. Secondly, it encourages them to actually scale the network as the demand actually increases and the requirements for applications increases over time as well. So it's not a network where you sit there, having been a dumb validator and do nothing. There's element of like participation that's required on a regular basis from validators to run SUI. Sam, you want to go ahead?
Yeah, the thing we really think about as the North Star with respect to decentralization is about third-party validation of state. Like, we're talking about how a validator is going to be really competitive, how you need a lot of operational sophistication. Well, the decentralization is about allowing anyone to participate. Not everyone's going to be a Google or an Amazon or like a sophisticated validator that can run a cluster or a small data center. But we do want it to be the case that everyone can validate the network or validate the subset of the network that they care about. So one important thing that we're doing along these lines is leveraging our data model is introducing this new kind of node that's like a full node, but we call it a sparse node, where instead of validating all the network traffic, where if you're pushing hundreds of thousands or millions of TPS, like that's going to be prohibitively expensive to do for a third party, you can say, I would like to track only the state related to these objects or to these addresses. And you can do this on sort of an individual level, like maybe a wallet is a sparse node that tracks the address that it's spending for. Maybe a game developer is a sparse node that tracks the objects involved in the game or the NFTs that game issues or the player objects or these sorts of things. And then you pay a cost for validation that's proportional to the amount of traffic that's going through your particular objects or addresses of interest rather than the network as a whole. And we think this is the way you really get to decentralization because anyone can run on their phone and have a completely verifiable view of everything that happens to the things that they own to the things that they own and not have to worry about the rest of the network. So that's really the thing that we focus on the most. I mean, of course, like there are many, many facets to decentralization, but like that's the thing where even as these networks really scale up, we think can still be tractable for everyone to do. Excellent.
So we did discuss a lot on the system side of things. So I wanted to now discuss a bit more on the business side of things. So what is the correct business development strategy for layer one? Like we are seeing different approaches being taken by different L1s. Like some are focusing more on Web 2, some are focusing more on Web 3, degen types of folks. Some are focusing on accelerators, hackathons. Some are focusing on grants to Web 2 projects. What do you guys think is the best way for L1 to scale in terms of network effects and from business development standpoint?
Yeah, so I want to take this from the top level to sort of describe what each of these sort of participants in the network, what their roles are, right? So why is it important to have a big ecosystem, a big community? They basically solve the cold start problem, right? For the developer to basically, these are the fan base that's going to be purchased their wares, going to be participating in their offerings. So that's very important to continue to grow their community. And it's also very important to grow the developer community because ultimately each one of the layer ones is a developer platform, right? The only way for layer one to be successful is for more and more specifications reach the audience. That you generate more fees and more activities on chain. So that's important from both angles, right? You do need people who are independent, small startup enthusiasts, right? They really, really fundamentally understand what is it they want to build, what is it they want to change. They're more willing to try new ideas and try things. They tend to iterate much quicker. But on the other hand, right, building a product is very complex. Look at all the gaming in the space. The independent studios just can't do it right because gaming takes a lot of money, a lot of time. So you also need to bring more established players. Veterans have built games before to come into the space, and ultimately you bring the two sides together, right? That makes a healthier ecosystem, which in turn bring other developer tooling, kind of service provider into the space. Because when you're thinking about building a developer platform, right? You build underlying technology, you build the essential tools and the essential libraries, reusable blocks. And early on, you have to build a lot of bespoke solutions for your partners to show them how to build these kind of applications, how to build new kinds of product. But that's not really a way you want to go for the long run, right? You want to abstract away all those complexities. You want people providing tools, ready-to-use libraries, and all that. And that requires third-party developer tool provider to come in. So that's, we're at the stage where basically cranking the flywheel, right? Getting all the activities happening on chain, getting all the community coming, getting some big companies to experiment with new ideas. And then it becomes more vibrant ecosystem. People will build more layers on top of it to abstract away blockchains. In the long run, if you want to build a Web3 enabled product, you shouldn't have to think about writing your smart contract. You should be thinking about these are the building blocks I use. These are the things I work together. Kind of like how Web2 company build products, right? You think about, do I use React Native for my front end? You use this back end, this kind of service, this kind of, product. You don't think about writing underlying protocols yourself.
Yeah, I want to broaden that in the sense that I think there's a lot of over-indexing on the existing market that exists today, namely the market that gets people generally excited, which is mostly DeFi, degens, and NFT enthusiasts. We like to broaden that market. Our goal when we set up to build Mist and Labs is to build the infrastructure that makes it possible for people to make asset ownership occur at scale. And to do that, you have to make it possible for existing businesses to integrate with Ledger at scale. And a few things we've been doing along those lines. One, it's the idea of sponsored transactions. And in SUI, you don't have to write a special contract to enable this, but every asset in SUI supports the idea of gasless transactions, if we want to call it that. And the idea is that I can, as a consumer, engage with a smart contract and gas is completely hidden away from me. Another account pays it on my behalf. And that's something completely transparent to the user, which is a big barrier to entry for many consumers. Imagine you want to onboard them into an experience. You ask them to go to an exchange to buy a token before they can start engaging. That's just a non-starter for like 3 to 4 billion people in the world. Secondly is the idea of even on-chain identity. We believe the way to actually scale Web3 is allow you to use your existing identities. So, for example, there's something invented by Miston recently called ZK Login, and what ZK Login does enables you in a completely decentralized form, but using only the chain as the authenticator to basically verify your existing Web2 credentials to create an account on chain. So the use case is I want to onboard into a game rather than being asked to remember some mnemonic or bring up some ledger device. I don't even know if the experience is going to be valuable yet. Why don't I just let people sign in with Gmail, Facebook ID, or even any kind of OAuth primitive that supports OpenID Connect? That's something that's going to be supported on SUI. Namely, now it means anybody with a Web2 identity amongst those partners, which are many, it's at least 1.5 billion people in the world, can leverage their existing identities that they've spent time curating in Web2 to engage in Web3 and not thinking about the chain. So you have two things. You're not worried, as a consumer, you're no longer thinking about gas, and you're also no longer thinking about, some crazy credentials you have to keep and store under your bed. So that is a Web2 experience. And we've always maintained Web2 as great product experience. I think Web3 needs to catch up there. Web3 has a lot to offer in terms of decentralization and ownership of assets and agency over ownership that we think Web2 just doesn't give. But what we're bringing is the Web2 experiences natively on chain. You do not have to use some third-party vendor for this to be something you can engage with on day one. And that's something we're very excited about, namely just bringing in more day-to-day users to leverage SUI. And the fact that it's very low fees means use cases that previously were not possible are now possible on SUI as well.
Yeah. Talking about day-to-day users, if I were to go and explore SUI ecosystem today, what will be some of the dApps you'll recommend I'll explore apart from the ZK login?
So there are a few things that you can explore on SUI today. There's SUI Friends, which is a showcase that we built that is an NFT project that enables you to engage with assets on chain. Namely, you can buy an NFT, and over time you're able to have accessories to it that you can basically onboard, and whether it's a shirt, whether it's a shoe, whether it's anything that's consumer related, you can adorn your NFT with that. And the reason why we've built that crafting tool is that's going to empower games to think about how they enable crafting within their games directly on chain and monetize that. There are also, of course, DeFi. There's KirkDex. There's of course there's DeepBook as well that is being built as well on Sui, which is a decentralized central limit order book they can use on Sui. Beyond that as well, we have a few other applications in a sense of, if I roll it off my hand, Sui Friends, Sui Name Service, Wormhole Connect, Turbos, which is a DeFi protocol, Cetus Finance, which is, I think they've already got over $30 million worth of liquidity. Clutchy, which is an NFT marketplace. Suia, which is a social app and enables you to build online communities. OneMind, an NFT marketplace. Keepsake. So we're seeing the ecosystem grow. I think we captured over 200 apps already have signed on to the Sui.network website. And that's only growing over time. So there's been a ridiculous amount of growth in the ecosystem so far.
Yeah, so starting from the 15th, I think the gaming partner is going to start launching, I think 2 per day from the 15th.
Yes, so I can even give you some alpha, right? I think between the 15th and the 21st, there's going to be Final Stardust, Project Loon, and Run Legends. So that's by Orange Comet, Arevant, and Talafo Games. And then all the way even into June, we have, OneNet, Lucky Cat, and Orange Comet releasing The Walking Dead, Panzer Dogs, and Bushi on Sui. So at least 14 games over the next 6 weeks are going to be launching on Sui, with 2 launching every single week. So there's going to be a drumbeat of activity and new experiences that we think are going to be super exciting for consumers.
Yeah, this is what I like to hear. So apart from these, since we have a very scalable infrastructure and we have very low latency, what are some of the unique use cases that you guys are excited about that we haven't seen yet, either from a token model standpoint or a business model standpoint, that hasn't been popped up and you guys think in the future, because of this infrastructure, will be something to kind of look forward to?
Well, there are a few things being worked on by our cryptography team that we can probably share more details soon, but one of them is private NFTs and time capsules. And with private NFTs, what it means is, I own an asset, but only I can see the high resolution version, or at least something private about that NFT as an owner, whereas the general public has no idea what the asset is, but they can only see partial elements of it. That's going to create new forms of activities for NFT ownership that we think just don't exist today. And then you add on top of that what we call time capsules. It's the idea that, some element of the asset can be revealed in the future time. So I will send you something today, and maybe on your birthday, you'll be able to unencrypt it and see what's inside the box. So imagine given red letters, and they could only open on certain days, and you know what amount you receive or what value you receive on a particular day. We think, Web3 should be fun, and, they call us a gaming blockchain, but we are more than that. I think everything we talk about here permeates just basic asset ownership of NFTs. It permeates everything you could do on a day-to-day basis. So the last segment of the podcast is a rapid fire round. Typically, we do it 1-on-1 and sometimes 2-on-1. So in our case, we have three people. Maybe we start with Evan. So this will be like a short response answer, right? So the first question is, Evan, what's your pet peeve in crypto?
I think people are looking backwards very much in crypto, and people equating crypto with Web3. People mostly don't understand what decentralization is solving from a sort of consumer behavior, or how products are getting built, and what's the problem in the world, in the internet today, right? And if you ask around, most people even in this space probably won't give you a good answer. Like, what is wrong with the internet today? Why do we even care about decentralization for consumers? That would be my biggest pet peeves.
Sam, perhaps you go next.
Too hard to define metrics for product market fit, and the speculative nature of crypto distorts the ways we would find that in other industries.
What about yourself, Dini?
Yeah, over-indexing on short-term gains or short-term value capture, and not thinking long-term. I mean, that's been my biggest, especially as a product person, right? Like, the short-term thinking mindset, and at least the I always say subsidy-driven nature of like the economic models that we see is just not sustainable. I'm surprised it's still here.
So when you say subsidy, are we talking about liquidity provisioning, or are we talking about grants from L1 ecosystem?
I think that for one, I can argue the grant system has just not worked. There are not many killer apps that have actually come out from grant programs. Separately, the idea that you can run a validator indefinitely and keep losing money and sustain it forever is just not something that you'd see in other businesses. I do think over time, when you can actually have apps that matter, that people use, validators can be successful and can be profitable. But today, those apps are very limited and only cater to a very small subset of the population, which we want to change.
Yeah, I mean, this is why several of the blockchains are inflationary, right? They're printing more tokens to pay for validator. Basically, they subsidize them forever and ever, right? I mean, coming back to the early answers, right? They have no incentive to improve upon their service in a lot of cases.
So the second question is, this might be a bit of a tricky one. Better tech or better network effects?
You need both.
Yeah, you absolutely need to have.
You need
Well,
both.
I mean, I'll say you need both, and neither is enough, right? You have to understand why they're important. Technology enable products being built rather than selling complexity in technology as a product themselves, which we're seeing left and right? 500 different roll-ups, different kinds of roll-ups, right? That's complexity as a product. So technology service products, network effects solve the cold start problem for product builders, but even those are insufficient, right? You actually have to sort of change consumer behavior, which means consumer to have to understand, coming back, what is the whole point of decentralization? Why is it important for they have agency over the assets own, right? Why does it improve upon their life? Then you have the whole thing actually going off.
I do think it's a good thing about this space that folks are very tech focused and they're very on top of what's happening and they get excited about new things. So it's actually possible to build network effects, at least from the best builders, by having really great tech or by doing something new. Folks are going to be interested in that and they'll try it out.
Optimizing for scalability or composability?
There's no, these are not the trade-offs, right? We have shown actually you improve upon composability because you're thinking about a different data model that allow you to capture the dependency, allow you to know whether there's conflicts between transactions. You can actually improve upon scalability and allow us to have object level composability, which cannot be done with anything else. So it's both. It's not one or the other.
Favorite thing about Web3?
Very fast iteration, right? People are constantly trying new ideas. And this is the way product should be built, is try new idea, doesn't work, or works to a certain extent, but fail to, kind of reach escape velocity. You try a different model, right? So I think Web3 enabled this, blockchain enabled this.
I like that folks don't take themselves too seriously, and although like there are serious responsibilities in building these systems and building these products, like there's always a nature of like poking fun or just a cultural thing that I think is pretty enjoyable and unique.
They have the good answers, honestly. I don't have much to add on that.
Last question before I conclude the podcast. Question I should have asked you guys but didn't.
Why are we so excited about SUI?
This is very technical, but I would have asked about programmable transaction blocks. We talked a lot about the sort of tech stuff we've been talking about for a while, but this is a very new and exciting feature that I think builders are really starting to figure out how to leverage, and you're going to be hearing a lot more about in the future.
Yeah, I think generally anything around developer productivity, right? Why we're taking the long road to like really change the game, right? Everything from the programming language, which others are using in terms of Move, but even beyond Move, we changed the programming model. And why is that, right? So again, this has to do with kind of capture dependency information and utilizing that in ways to process a kind of transaction more efficiently and have a better data model. Everything works together, right? This is why I don't believe in this concept, a lot of things that's been bandied about. Like this is the first industry in the world where people are sort of allow the existing programming models sort of throw away information that can be used to improve upon your system, right? nobody think about critical information like dependency.
Thank you guys for joining us today. I learned a lot about SUI, and I also learned a lot about you guys. So again, thank you very much for coming, and I think we're on time as well.
Thanks, Mehdi. It was our pleasure.
Thank you for your time.
Wow, what an interview. Personally, I think Evan, Sam, Idini are gigabrains. If you agree with me or if you disagree with me with regards to the fact that they are gigabrains, please comment below, give me your feedback. And whilst you're at it, also hit that like button. So in this last segment of the podcast, I actually go about summarizing some of the points discussed, decipher and make some of the content easy to digest. So I'll share some of my summary notes with you guys, and I also leveraged Masari Twitter thread that kind of summarizes all the points discussed in a very visual way. So in terms of in terms of various topics discussed, we started off the podcast with SUI's Object-Centric data model. Now, this is very important, and it's a 0 to 1 kind of innovation. The reason why SUI is not using the original programming language Move, which was created in Facebook and is also kind of leveraged by Aptos, they have done this innovation to do few things. So the first thing that Evan highlights was the fact that because of this project-centric data model, you get that expressivity that allows you to create assets which are more complex. So just to give you an example, you can create an object as an NFT, and that NFT can own other NFTs, could have a child-parent relationship, could basically do interesting things with regards to what's happening in the real world. Its metadata might change. And you don't have that currently with EVM. So that's number one reason why object-centric data model helps. The other part, the more important part, is that in SUI's world, transactions can be grouped by object and then can be processed in parallel. So this diagram which Masari made kind of summarizes this very eloquently. So imagine you are minting an NFT. Let's say there are two folks, me and you, we have been minting NFT here, and there are folks who are doing liquidity mining on a DEX. Now, these two transactions might be independent of each other, and they might not interact simultaneously with each other. Because of this, I'm minting NFT and somebody else is doing liquidity mining. These transactions can then be processed independently by the computing resource. Once that's done, these validators can process this transaction independently, but can also scale the transaction horizontally when they have more compute. So this is one of the innovation that is being brought by SUI via their object-centric data model, which helps in parallelizing objects. Now, another thing that's very unique about SUI, again, I've touched upon this earlier, is that simple transaction, let's say peer-to-peer transfer or NFT mints, can be done without consensus and without ordering of transactions. And that also allows transactions to be done quickly. However, when it comes to shared or complex transactions, so for example, me minting NFT, then doing lending and borrowing, and then going to a DEX, all of these in one go, for that purposes, it has to go through ordering and consensus. And for that, they use Narwhal and Bullshark, which allows them to do this. Another interesting use case of SUI token, and also something novel about this project, is the tokenomics, which from an intellectual standpoint also made me very curious. So one thing they're innovating on is that they have a on-chain storage, which a lot of L1s do not have, or even if they do have, it's very expensive. So when you are using gas, or when you're using SUI token as a commodity, you're not only paying for computation, but you're also paying for on-chain storage. Now, this is very important because let's say if your on-chain activity leads to clog of future validator set, there is opportunity cost. And bad actors, if given if there is no storage cost, bad actors can just spam the blockchain. To avoid this bad network externality, They have a unique token utility where you also have to pay for compute, which also creates another sink for the token and creates additional utility. And I think it also kind of solves that time travel issue where validators in the future will be storing way more than current validator sets. So I think that is also very noble, which I don't think, apart from near any other blockchain, is kind of thinking about or doing. One thing I missed actually on the podcast was programmable transaction blocks, which is again another dev tool SUI is working on. So programmable transaction blocks actually allows users to create composable sequence of many transactions, let's say 1,000 transactions, that can all be executed at one go. So for example, think of it as like packaging. You can package multiple operations in one go. So since you're packaging multiple transactions in one go, the chain again achieves throughput and it also lowers cost per transaction. So let me give you some example. Mass minting of 1,000 NFTs. All of this can be done in one go, and sequence of 1,000 transactions can be used as one. Sending payments to multiple parties, or doing complex arbitrage or triangular arbitrage or DeFi derivative strategy, which has multiple sequences, all of that can be done in one go with lower cost. And that is something that they've also introduced, which from a developer standpoint is amazing. They have other innovations as well, such as subsidizing gas fees on the back end, which I think is also interesting. Evan is also a visionary. Like, you can sense that he hates skeuomorphic products, even like in Web3. And that was evident the way he started the interview, and also when I asked him about his pet peeve. So the reason he created this expressivity with the object-centric data model was to avoid that and create these unique use cases that Web3 should be useful. So I thought that was interesting. Also, there was a lot of alpha kind of leak, but also discussed with regards to different projects being built. And there were a lot of names that were dropped. So do check out. So if you're just looking at the synopsis or the summary of the podcast, I urge you to go back and listen to the whole podcast till the section where Edini gives you the alpha. Again, thank you so much, guys. And I do appreciate you listening to the whole podcast. If you have made it till the end, again, please hit the like button, subscribe, and share your love on Twitter.
This podcast is for information purposes only and should not be considered as financial advice. Any opinions provided in this podcast reflect the views of the speakers only.